All right, these are the answers to page 650. Sigma notation. What you're looking at is you're adding from the first term to the sixth term of a sequence that's defined by this right here. So what we can do is work those terms out. Just put 1 in. 3 times 1 is 3 minus 1 is 2. Then put 2 in. Then put 3 in. Then put 4 in. Put 5 in. And then put eventually 6 in. And then once you have that, go ahead and multiply it all together, and you should get, I believe, 57, or I'm sorry, add it all together, and we should get 57 for our answer there. Sorry, that took me a little longer than it needed to. For 76, the first term of this sequence will be 5. In fact, all the terms of this sequence are 5. So the first term, the second term, the third term, the fourth term, fifth term, all 5. And so we end up with 25 as our answer there. For 78, we're starting with term 0. So if I put 0 in, I get 0 squared times 2, which is 0. Then we can put 1 in. 1 squared 1 times 2 is 2. Then put 2 in, we'll get 8. Then put 3 in, we'll get 18. Then put 4 in, we'll get 32. And then eventually put 5 in, and we'll get 50. All right, go ahead and add all that up, and you should get 110 for our answer there. For number 80, we're going to start with the third term and go to the fifth term. So if you put 3 in, 3 squared 9 minus 3 is 6, so we'll get 1/6. Now put 4 in, and we'll get 1/13. And put 5 in, you get 1/22. All right, add that up, and you should get 124 over 429. If you do it as a fraction, as a decimal, it's going to be something around 0.25-ish, right? 0.2. Somewhere, it's about 1/4 if you do it that way. All right, 82, you're putting 1 in. We get 1 minus 1, which is 0, plus 1 plus 1, 2 to the third. So we're going to get 8 for that first term. Put 2 in, we're going to get 1 squared, which is 1, plus 3 to the third, which is 27. That's going to give us 28 for that term. Put 3 in, we're going to get 2 squared, 4, plus 4 to the third, which is 64. That's going to give us 68 for that. And then put 4 in, we're going to get 3 squared, which is 9, plus 5 to the third, which is 125. That's going to give us 134. All right, add that all together. You should get 238 for that. All right, and then on this one, if I put 0 in, negative 2 to the 0 power is 1. Put 1 in, I'm going to get negative 2, then positive 4, then negative 8, and then positive 16 when I put the 4 in. Add that up, and we should get 11 for our answer there. All right, 89 wanted us to just write this in terms of a sigma notation. We didn't have to evaluate it, just had to kind of write it. So you can see that we'll use I for us, but you could use J or K or some other variable if you want. Just don't use X, that's not necessarily the place for it. But if we use, say, I, we see that the I is going from 1 to 9. So we're going to go from 1 to 9. And how does this look? Well, it's 1 over 3 times I. Right? That's what each term is doing. The 1 and the 3 are constant. The I is the thing that's changing. Right? Same thing here. You can see we're going from 1 to 15. So I'm going to go I equal 1 to 15. The 5 is constant. The 1 plus is constant. It's what the 1 is adding to that's changing. We'll make that the I. For 91, we're going from 1 to 8. So I'm going to go I equal 1 to 8. And what is constant? 2 times the 8 on the bottom plus 3. That's a constant no matter what. The thing on the top, however, is the thing that's changing. We'll make that an I. All right, 92, I can see that I'm going 1, 2, all the way to 6. So we'll go from 1 to 6 here. And I can see that the 1 is constant, the minus is constant, the divide by 6 is constant, the square is constant. All those things are constant in all of these terms. The only thing that isn't is the 1, 2, 6 part. So that's the part that will make the I there. Okay. All right, 93, I've got 1, 2, 3, 4, 5, 6 terms. So I know that I'm going I equal 1 to 6. Now, I have to come up with a general term for these. So it looks like we're multiplying by something here. It looks like we're multiplying by -3 to get from term to term to term. So we'll go negative 3 to the I power. So if I put 1 in, I'd get negative 3 to the first. If I put 2 in, I'd get negative 3 to the second, which is positive 9. So those are going to be the terms I want, except I want the opposite of these. So I'm going to multiply by a negative 1 out here. All right, so that'll give me a general term for that right there. That'll get the job done. For 94, I see I'm going from 1 to 2 to 4 to 8, all the way up to 128. So if I kind of think this through, let's see, this would be like 2 to the, well, let's just go 1, 2, 3, 4, then 16 would be 5, 32 would be 6, 64 would be 7, 128 would be 8. So we're doing 8 terms. We're going to go I equal 1 to 8, right? And you can see to get from term to term to term, we're multiplying by negative 1/2. So we're going to put this negative 1/2 to the end right there, okay? So what would I have to, if I were to put 1 into this, I would get negative 1/2. What would I have to multiply negative 1/2 by to get it to equal positive 1? And that would be a negative 2. And so this right here will get the job done. If I put 2 in, I get 1/4 times this, which give me the negative 1/2, and then we're good to go. Now there's other ways to do that, and and we'll get into those next week when we talk about it, but like I said, that gets the job done. All right, this one here, 95, I say I go 1, 2, 3, 4, all the way to 20. So we'll go I equal 1 to 20 here. And the 1 is a constant. The one thing that isn't a constant is that we're alternating here, right? So I'm gonna go negative 1 to the n, but if I were to put 1 in, that would give me a negative right away, and I don't want a negative right away. So I'm actually gonna go negative, going to n minus 1. This is gonna put an alternator on my terms, which will make them go from positive to negative, and it will line up exactly with the way that I want the terms to be. Now I could have done that at any point that we had an alternating sequence. I just chose to include it in the, the thing we were multiplying by, but this is a little thing that we can do. Anytime we wanna make an alternator on something, we can do that, okay? Now we're gonna have a 1 over and something squared, and that something squared will be the I. So 1, 2, 3, 4, 20, 1, 2, 3, 4, 20, we're gonna put that in. That's what we're gonna have right there. All right, then 101 wants us to find the third partial sum of this infinite series. In other words, just add up the first 3 terms. So if you were to put a 1 in, 4 times negative 1/2 is negative 2. Now put 2 in, you're gonna get 4 times 1/4, which is 1. Put 3 in, and you'll get negative 1/2. Put that together, we get negative 1 1/2 as our answer for that.